Anyone can tell me normally when we will do tuning? Normally. You will start tuning from your side, or anyone ask you to do the tuning, or when that situation will come. You need to go for a tuning when that situation will come. So normally, if any developer or end user, they will give complaint sometimes. Complaint means they will send a mail or they will ping so and so query. Until yesterday worked fine, today not working fine. Until yesterday it's completed in 1 minute, but today it's taking 10 minutes. Some people will say, hey, each and every query until yesterday worked fine, but today not responding properly. It's taking huge time. Like that, the first complaint will start actually. Whenever anyone given complaint, what you need to do? First you check how many number of processes running in the server. Anyone can tell me what is the command? How many number of processes running at OS level? PS-EF, WC-L. If count is showing bigger, find the how many processes running with the Postgres user. PS-EF grab Postgres, WC-L. First number of processes. After that, we will check the CPU usage. After that, check the one load average. After that, memory. So these are the four things first we will check. Number of process, load average, CPU usage, memory. These four things first we will check. If everything is good at operating system level, these four, then log into the database and check how many connections can running in the database servers. Select count star from pgstat activity. Okay. If you are seeing huge number of sessions, then you find like user wise. User wise select username, state, count star from pgstat activity, group by username. Okay, group by username comma state actually. So which user, how many sessions, active, inactive, idle, that one will be entered here. Later, check the specific query waiting state is true or false. Check the specific query waiting state is true or false. If waiting state is true, yesterday I given one query to find out the blocking sessions, right? Find out is there any blocking sessions causing. If any query is blocking other query, you check first. Once find the blocking session, if any blocking sessions are there, immediately send mail to application team. So and so connection is blocking so and so connection. That is the reason you are seeing slowness like that. You send it. First 7 points is good. For example, whatever the 7 points we discussed, if it is good, then what I can do, I will check statistics. When was the last vacuum performed? When was the last analyze performed? I will check. In this case, if last vacuum performed and last analyze date more than 7 days. More than 7 days means we will treat like a old. Already it's expired. Stats expired. Then I will run the vacuum and analyze freshly. Okay. After that, check whether any query generating huge temp files or not. Check whether any query generating huge temp files or not. That is also important. How you will check it? Temp file sizes, temp files, number of temp files, and temp file size database wise, and deadlocks also you can get from the pgstat database, right? From pgstat database I can get it. Next one, check is there any data tuples in the respective table. Anyone can tell me which table to find out the data tuples? pgstat user tables only. The table will contain data tuples information. Check whether is there any bloat in the specific table. Bloat query I given already. And one more thing, check whether the table has indexes or not. That is also important. If the table has indexes, check the index bloat as well. Okay, total All points I'm checking actually. First, number of process, Postgres process, okay, CPU usage, memory usage, load average, number of sessions running in the database, user-wise sessions, deadlocks, blockings, temp files, statistics, okay, bloat at the table level, bloat at the index level. These all the 12 points I will check actually. These all queries you keep it in a single file from the file. So all 12 results comes at a time actually. If everything is good and as expected, now I'll go where what I will do actually, whether this query is sorry, then I will ask that guy whether this query executing first time or not. Sometimes first time itself the query will take time. Sometimes they will say two scenarios. Until yesterday query running fine. Until yesterday it's completing in 1 minute. Today only taking more than 1 minute. That kind of situation will come. So you need to check the query designing standards as well. If it is a first time executing query, you need to check the query designing standards. What are the designing standards? First, that whatever the query they are using, right? In the query, you need to think there should be no join condition. There should be no join condition between non-indexed columns. Sorry, there should be no join condition between non-indexed column. Two tables are there. If you want to join two tables, both the side common column required. That common column should have index. Index actually employee table, employee number, department table, employee number. So if you want to join the two tables, both the sides that column should have index. If there is no index on the column, don't perform join condition. Second thing, very bigger table, very small table, don't perform join. It will leads to product join, very critical. At the same time, there should be alias names properly. Otherwise, it will leads to product join. First thing, no join condition between non-indexed columns. Don't join bigger table and smaller table. Be careful while creating the join alias names. Now coming to the joins actually. Popular join, everyone knows that actually. Join means get the data from multiple tables together. Get the data from multiple tables together. Employee table, department table, HR table is there. I want to join both all the three tables and I want to get the data. So for that, I will use the join condition. The first inner join. In the joins, we have sometimes first is the inner join. Inner join means if you have a two tables, but first thing to perform the join, you need a common column, right? You need a common column. If inner join performed on two tables, common columns will be printed. Common columns only. So let me show you that one. You people tell me result set. I don't know. PS-EF grep Postgres. Yesterday someone asked, hey, why Rambabu, every time you are starting services? Today I have started. I have not started. Yesterday I enabled auto startup, right? So that's the reason services came up automatically. Su-Postgres. Login. Let's check. Lot of tables are there. I don't bother. Table employee 2022. Okay. Nothing is there. Let me create one table first. Employee table. See, number, integer column, name, varchar column. Okay. Let me insert data. And then create the table. Department. Insert into. Insert into. Insert it, okay. Like this. Select star from employee. Select star from department. Okay, one table has 2 records. Another table has 3 records. Can someone tell me what are the common records? Common employee number, which one?
Number.
1 and 2. No. Value I'm asking. Common column number, okay. Employee table has number column, department table has number column. Common columns 1 and
2.
1 and 2 only. So how the inner join will print the results at C? Select E dot number, E dot name. That means from employee table, number and employee table name will be displayed. D dot department, D dot D name. From department table, department name. From employee, inner join, department D. C, employee E. Employee table alias name E. Inner join for department alias name D. On D dot number equal to D dot number. E dot number equal to D dot number. See, wherever number 1 and 2, these two are the common, right? These two are the common records. The 3 printed. This is inner join. We will call it as inner join. For example, if you generate explain plan for the, if you generate explain plan for any query, see any query you can generate the explain plan. If you generate, what will happen? It will give you estimation cost actually. Okay, estimation cost. How much time required to execute the query? What are the steps happening inside? That one will be printed. Okay. So see, in my case actually, how many tables are there? 2 tables. First, sequential scan. See, sequential scan on which table? Department table, right? Then sequential scan on which table? Employee table. First what it is happening actually in employee table, it is scanning based on the number column. Department table, it is scanning the number column. Then at the same time, what it is doing? Merge join. The employee table result set, department table result set, both it is merging, right? See, merge join. Both it is merging. If you see the cost actually, what is the cost? See here, cost actually, how much value? 176 starting, 303 ending. So what is the final cost? Final cost. Select 303.67 minus 176.34. Okay, 34. See here. First one is the starting cost. This one is the ending cost. If you want final cost, what we need to do? Ending cost minus starting cost, right? How much is the cost now? 127.33. 33 actually. This cost you can the cost is there, right? You can convert it as a timestamp actually. Very easy. How to do that actually? So CPU tuple cost in your server. Anyone can tell me what is the tuple? Tuple means attribute means
Column.
attribute means column. Right one. This one is the column. Attribute means tuple means record. 1, 2, 3, Sam. This one. This is the tuple actually. Okay. Tuple means one record. One tuple. How much CPU consuming? 0.01. So what I can do here? Select. Cost is there, right? This cost by 0.01. It will give you the timestamp. It will, how many? This one, see, if you observe actually, wait. So, how much is this one actually? 12,733 milliseconds. So that means how many seconds? This is this value in milliseconds. First, you can find the final cost. This is my final cost. So this cost 127.33, you convert it as a timestamp. 127 by 33, 127.33 by 0.01. So I got 12,733 milliseconds. Milliseconds, how to convert as a seconds? by 1000. So how many? 12 seconds actually. This query execution will happen 12 seconds. 12 seconds means good or bad? This is a very small query.
Bad.
Very bad. If you observe clearly, when sequential scan happening on the department table, how many rows it is looking? When sequential scan happening on the department table, 1270 rows reading. When sequential scan happening on the employee table, 1270 rows are reading. But actually your employee table has how many records? 2 records. Department table has how many records? 2 records. Why this has happened? Anyone can tell me? The table has any index? /D employee table /D department table. Employee table or department table has indexes or not? Anyone can tell me?
No.
All right, both the tables don't have any index. That might be the culprit, right? So what I will do here, see, let me create the index on the employee table. See, create index name on employee table number column. Create table, create index department on department table. See, both the employee table, department table number column I created index, right? Create index name on employee table. Create index name on department table. I created 2 indexes actually. Okay, department IDX, employee IDX. Both indexes I have created actually. Once I created, how you run the same explain plan for the same in the inner join query? Earlier we done inner join, right? See, select E dot number, E dot name, D dot name from employee, inner join, department D, right? See, if you observe, sequential scan happening on employee table. How many rows reading? 2 rows. Sequential scan happening on the department table. How many rows reading? 3 rows. Instead of merge join, hash join happening. What is the final result? How many rows final result? Huh? 2 rows. So which explain plan is correct? This explain plan is correct or bottom one is correct? Which one is correct?
This one.
Bottom one is the correct. Why?
This one.
After you created the indexes, it is exactly taking the rows. Now we'll see how much time it will take for execution. Select and someone tell me, I need the final cost. How to find the final cost? This is the main cost, hashing join. So this is the ending cost, sorry, starting cost. This is the ending cost. So what is the value? 2.11 minus 1.04. 1.07 is the cost. Convert this to time. 1.07 by 0.01, right? CPU tuple cost. So how many milliseconds? Around 100 milliseconds, right? You execute this query 100 milliseconds taking, very faster. Okay, like that you can create the index on the join column actually. Then it will be good actually. Okay, and one more thing. Do you know table size means? For example, I have a table size 1 GB, index size 500 MB. If anyone asks table size, how much you will tell? Table size 1 GB. Index size half GB. If anyone asks table size, how much you will tell?
1.5.
1.5 GB. Table size means table size plus index size. Remember that one. Next, after inner join, what is left outer join?
Ram, regarding that one, the number of rows that is returning more. So from where it is getting that many records?
Where is getting?
That many records in the merge join.
You tell me why it is getting like that. What is the meaning of product join? Product join means
all the possibilities.
Right?
The cross join.
Same number of records printing actually. Same number of records reading. So you have a 10 rupees. If you count the 10 rupees 10 times, it is 100 rupees. But is it really 100 rupees? All right, 100 rupees only. So that is the reason we will call product join is the separate one. Okay. So see here. Now we are going to left outer join. First inner join done, right? Now left outer join. See carefully. If you performing left outer join between two tables, employee table and department table, which table is left side? Which table is left side? All records from the left side table, common records from the right side table. See, left outer join means select star from employee is there. Okay, select star from department table is there. Employee table 1 and 2, department table 1, 2, 3. Okay, three records are there. If I perform employee join, employee left outer join, for example, department table, what I am saying, all records from employee, common records from department table. Can someone tell me how many records will printed? These two. If I join employee left outer join department, how many records will printed?
2 only.
2 only. Select star from employee left outer join department T on T dot number column. Employee table number column equal to department table number column. So only 2 rows. For example, if you do reverse, what will happen?
3 records.
Instead of left outer join, I have a right outer join. All records from right side, common records from left side. See, that right side one, all records, right? Left side one, only common records. So this is right outer join. You can do left outer join and you can do right outer join as well. Okay. For more information, joins, a lot of types are there actually. Examples also. You can go with this blog, very nice blog actually. Okay. Now, see here. So 3 conditions I told, right? Actually, 3 conditions. So if there is no index, and one more thing actually, join between bigger table, smaller table, and alias name is not proper, you give this one actually. Suggestion to application team. Hey, this is not the correct design actually. You change it. You cannot change. As a DBA, you don't change. You are not authorized to change. Let them change. Let them change, let them test, and let them come. Okay. So, like that, we will do that actually. Now, 1 minute. So, what is product join? Product join, every time, lot of people will say, hey, product join will happen actually. But can we see that? Bad thing we cannot see. Product join. Then where is the proof? Very simple. For example, Karthik has 10 rupees, Rambabu has 5 rupees. Okay. Normally, Karthik 10 only, Rambabu 5 only. But if luckily Rambabu and Karthik friends, so how much it will be? 10 plus 5. Any possibility 10 plus 5 will become 50? No. When it will become 50, if I count 10 and 5 rupees multiple times, then only it will become 50. But is there any use with that counting multiple times? No use actually. That is, we will call it as a product join. So always try to avoid the product join. If you are not avoiding, same number of records, keep on reading and keep on counting. Okay? Like that. That's the problem. Now, see here. Convert cost I done already. Here, see, if you observe actually, one thing happening here. The explain plan. This is my explain plan. Which scan happening on the table? Sequential scan happening on the employee table. Sequential scan happening on the department table. Okay. So what is sequential scan? If my table has 100 records, if I am performing a sequential scan, what it means? It will read all the 100 records in the table actually. Okay, one by one, it will read it. For example, if I am doing index scan, for example, whatever the 1 or 2 values in the table, out of 100, what are the 1 or 2 values required? Critical, only it will read that 2 columns only. Okay, which is good? Sequential scan is good or index scan is good? Normally.
Index one.
Index scan is good actually, normally. But we cannot say all the times index scan is good. Okay, we cannot say all the time is good. Index is good, index scan. Sometimes sequential scan is also good. PostgreSQL equal optimizer aware, which is good one, it will pick up that one only. See, for your information, /d plus employee table has member column, name column, D plus department table. My department table has number column, department name column. Okay, both the columns. Now both have indexes. The employee table has index, department table has index. Still, explain plan using index or not? See, this explain plan using index or not? Anyone?
No.
Not using. Not using. I'm saying optimizer knows which is good plan. The index is good or bad, optimizer knows. That's the reason optimizer not picking up the index in the plan. So, but you are not satisfying with that word. I'm saying, hey, optimizer will choose best plan, but you are not accepting. No, Rambabu. That optimizer to use index forcefully. Okay, can do that. How to make forceful to use the index? The execution plan. See here. We have an option called show enable sequential scan. Always it is on. You make off set enable sequential scan to off. Okay, to off. Just session level I'm doing. See, enable sequential scan option off now. Turn off. So now check actually. Now check the explain plan. What will happen? We'll see. Whenever sequential scan stopped, what it is doing optimizer? It is doing index scan only, right? Okay, index scan. It is using index scan. But the bad thing is cost increased or decreased. Compared to earlier just 7 milliseconds, right? This time we'll see 20.36 ending cost minus what is the starting cost? 0.26. This is the cost. Select its cost by 0.01. So how much time taking? How many milliseconds? 2400 milliseconds taking. But earlier my one just 7 milliseconds.
100.
Previous one.
100.
This one 107 milliseconds. See how much difference? Okay, so this is the way. Optimizer knows that index scanning is good, sequential scanning is good. Optimizer knows that. You don't explicitly go and don't do this kind of cunning things actually. Okay, it will not work out. So that's the reason my optimizer not using the index scan. Why? Sometimes indexes are good, sometimes bad actually. Okay, remember that point. So next, for example, see here. At any point of time, multiple nested joins not recommended. What is multiple nested joins? Join inside join, right? Multiple nested joins, that is not recommended. So it will take some time. First parent query, first child query 1, child query 2, like that. At the end, parent query will execute. So it will it is not recommended to use the multiple nested joins. Okay, later after multiple nested joins, so you may get it out easily. Rambabu, okay, I will not create the multiple nested joins. Multiple nested join means, see, select employee number from employee table where employee number in. Inside, select employee number from department table where department number in. Inside that, select something like that actually. Okay, so join inside join, we will call it as a nested joins. In that case, better, instead of going with multiple nested joins, you can create a temporary table for all the child tables together. The child table, keep it here. Okay, so what will happen? The child table query result set will pass to parent table. You will get the result set as expected only. It is a little bit faster than the multiple nested joins. So see what I am saying. Don't use multiple nested joins. For example, see, I am creating a table. Create temporary table. For example, see, if you create temp table, what will happen? See, clearly mentioned, create temporary table. Okay, insert into EMP values, generate series. I am inserting 1 to 1000 records. Check the count, select count star from employee temp. How many records? 1000 records. Now, for example, see, instead of multiple joins, what you need to do now? Select star from so and so table, condition. Inside that, use the temp table. Your result set will be very faster. See, employee temp 3 is the table. Just exit and log in. What will happen to the session? Where is your temporary table? Only 2 tables are there. This third table, first table gone. That means temporary tables, permanent or session specific. Temporary tables, session specific. If you come out from the session, automatically this one will be gone actually. Okay, temp table will be gone. And one more thing. For example, see, if you found more aggregate functions, sum, minimum, maximum, count to in the same query, some people without having proper knowledge, they will create a query with multiple aggregate functions. Aggregate functions mean the sense sum, minimum, max, count to, average, lot of things actually. Those are we will call it as aggregate functions. It is also not recommended. It will kill the huge performance. Okay. And one more thing actually, yeah, I told this one. Sometimes some people will request, Rambabu, please, this one actually, give bigger work mem to my user. So yes, we can do that. Alter user username, set work mem to so and so value. This one also I can do that. Then that query is related to you, that whatever the queries are there related to that user, they will get a good performance as they are getting a more work mem. Okay. Now see here. This and all okay. Redesigning part okay. But at the end, sometimes this situation will happen. Rambabu, this is fresh system. Complete fresh system. We don't know how much CPU, how much shared buffers, how much work mem, how much max connections, how much temp buffers. We don't know what value should be the good. So please let us know what are the values. Then start the services. Like that, some companies will ask. Don't worry, you no need to come to me by that time. Simple, you can go to this website. pgtune.leopard. This one is there, right? Go to the Google directly. Whenever if you get a fresh system, if you want to tune the system, see PG tune leopard in.ua, right? So simply go here. What you can do, parameters of your system. First, in my case, which version? PostgreSQL 14, for example. Linux, operating system Linux, Windows, other operating system. Linux. Which DB it is? Database type. So normally, OLTP means only write operations. Normally. Database type, web application means select queries, online transaction processing, OLTP, data warehouse means only writes, desktop application, mixed application. Always go with the mixed type. Mixed type means what is that actually? Selects, inserts all the queries, all kind of queries I will run on the database. For example, my system RAM is 8 GB. Number of CPUs, I have 4 CPUs. I want to connect 100 connections at a time. So, and one more thing, storage. My storage will be always, anyone can tell me in real time, SSD or SAN storage. Which storage for the servers?
SAN.
Always SAN, network storage. Okay. SSD, hard disk, that one only for laptop storage. Okay.
Laptop.
Hard disks. But we will use SAN only, network, SAN storage. Okay. So now do one thing. Generate, click on generate. If you click on generate, see max connections, shared buffers, effective cache size, maintenance work mem, checkpoint completion target time, wall buffers, statistics target, random page, work mem, minimum wall, maximum wall, parallel workers. Some options given, right? Almost 15 or 16 parameters. If you change these parameters in PostgreSQL.conf file and restart services, that is enough for your server actually, any new server. Okay, like that you can do that. Any new server, if anyone asks you to do the tuning, just take this 15 parameters, update it, enough. Like Oracle, there is no concept of this one actually. Oracle, you have this one, right? Plan hash value. Yesterday, same query taking one plan hash value. Today, it's taking another plan hash value. That kind of concept not there in the PostgreSQL. Remember that. Why? PostgreSQL always choose the best least cost execution plan. So that is the reason you don't have any plan hash value concept. Okay. Now see here, for table size tracking, always best practice, you track the table sizes. Why you need to track the table sizes? Some people will give complaint. How they will give complaint? Hey, until yesterday that query running very fast. It will complete it in within 1 minute. Today it is taking actually 5 minutes, 6 minutes like that. Definitely, I will ask one question. Hey, have you done any data loading yesterday night for this table? He will say, no. Seriously, I have not done any data loading. That is the first lie we will listen from the developers. Maybe they might not have. Yesterday night, they might done a huge data loading. 2 GB, 3 GB data they might have loaded to the data table, but they will not reveal that one. They will not reveal to DBA1. So you don't believe developers. What you need to do to track the sizes from your side. See, for tracking data table sizes, I am creating a one table. Create table DB sizes. Log date. Just take this. Create table DB sizes. Select star from DB underscore sizes. So this DB underscore sizes has how many columns? 3. Log date, table name, size. Total 3 columns is there. So now you run this query daily. For example, I am running this query, insert into DB sizes. For this table, I am inserting data. Where I am getting the data? This is the query I am using to get the table sizes. This one, select namespace, relation name as a table size. Okay, the details I am getting and I am inserting into the DB sizes table. Copy, insert it. See what will happen now? Select star from the DB sizes. So timestamp, which table, how much size, all the details inserting into the DB sizes table. For example, see, all are 16 KB and all. If insert into employee, select star from employee, I am doing huge data loading. Almost double I'm making, we'll see. Insert into DBT, select star from department table. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Okay. For example, check this sizes. Employee table 18 MB, department table 472 KB. So now again, as it is, see, for example, next day, my cron schedule will work. My cron will execute this command. This command daily it will load table sizes into the DB sizes table. For example, this one. Select star from date wise it will store, right? DB sizes. See, if you see, you got the complaint for employee table. Select star from DB sizes where table name equal to, for example, public.employee. This is my table. So if you see employee table size, first 8 o'clock 16 minutes, it is 8 KB. 8 o'clock 17 minutes, it is 18 MB. For example, this is yesterday date. This is today date. You can see you easily difference, right? How much size difference is there? You can easily see that actually. So they cannot escape. Hey, yesterday night you have done a huge data loading. So I have the matrix. So they cannot escape it actually. That's the reason you need to schedule this part actually. This insert script is there, right? Daily it will insert data into this table. You just schedule this line in the on tab. Okay, like that. And one more thing. Sometimes they will before only they will say. They will go for data loading maybe tomorrow or day after tomorrow. They will say 2 days before, hey Rambabu, please optimize the system. Okay, we need a better performance. During data loading, we should not see any performance issue. We change the system accordingly. Yes, we can change it. How to change it? First, there is a parameter called default statistics target. Oracle people are aware of this one. In Oracle, if you run the analyze, if you run the gather statistics, you will give one thing, percentage. What is that percentage? Gather stats percentage.
Whether it is a full table or half table.
Full table
Depends.
or half table or still
The amount of
percentage. Percentage of the table should be analyzed. Should be stats collected, right? Here also same thing. Default statistics target value 100. That means if you run analyze on any table, if you collect statistics on any table, by default it will go for a 30,000 rows actually. Okay. Out of table has 10 lakhs or 15 lakhs or whatever it is. Only for 30,000 rows it will perform the analyze sample. See, analyze verbose employee table. For example, if I do analyze an employee table, so here how many rows in the sample? How many rows? 8,000 only the sample, right? This is due to default statistics target 100. Now you have decided 30,000, very less number of rows. So I want to scan at least 60,000 rows. How to do that? Set default statistics target to, for example, 200. See. So default statistics target 200 session level. Now run the analyze. How many rows? 60,000 rows, right? So to speed, to complete very faster, which is good? Default statistics target 100 or statistics target 200, which is better? Complete faster. Complete my analyze faster, which is better? Default statistics target 100 is better. Then only it will complete very faster, right? Analyze operation. So you keep this value as it is. During use data loading, definitely auto vacuum will trigger the analyze operation multiple times, right? So that's the reason if you keep it as it is, it will complete very faster analyze operation. Don't increase the value, better value. Next one actually, constraint exclusion. For example, one simple table is there, I'm inserting data. Okay, see, one simple table is there. Create table HR, number integer. Number integer, I'm inserting data, insert into HR, values actually generate underscore series 1 to 1 lakh. 1 lakh, for example, 1 lakh records you are inserting. Okay. Don't insert, first check the timing. How much time it will take. Slash timing is, it will capture the time. So for example, see, how many milliseconds? 173 milliseconds taken. Whether this table has any constraint? HR table has any constraint? Constraint means not null, to check that one, right?
No.
I will do one thing. Create table, news, number, integer, not null, unique. Two constraints I'm giving for the table, okay? Giving. So let me insert the data, into same news table. Okay. So what happened? Any difference? Earlier, same 10 lakhs, 1 lakh records inserted into HR table. How much time taken? 173 milliseconds. After that, I created another table, but for the number column, this time what I have added? Not null constraint, unique constraint. Two constraints extra. So what is the time now? Wait, insert into news values. Yeah, it's failed actually. Wait, my bad. Table I create, table itself not created. Okay. Let me. My bad. Sorry. Create table integer, not null, unique. Okay, table created. Let me insert data into news actually. So how much time taken it one? 600 milliseconds. But same number of records, 173 milliseconds. What is the difference? Same insert query, 170 milliseconds. Same insert query, 600 milliseconds. What is the difference? Why?
400.
Start taking more time.
Why?
Because it is checking the constraint before inserting.
Here constraint. So constraint is good or bad? Drop. Alter table, you can do it actually. Alter table. News. Drop. Drop constraint. So first unique key drop it. Next not null also there, right? Constraint alter table drop constraint not null. It is not constraint actually. That's the problem actually. Okay, you can modify the column also. B plus which one it is news, right? News table. So not null, still not null is there. You can modify the column. Alter table news modify alter table name alter column. Okay, column, which column? That one, number column. Modify. Okay, column number type. Okay, no, not type this one actually. Constraint, right? Reset. Yes. Reset constraints. Okay. Check. Nonsense one is there. Constraint exclusion. Okay. Something else actually. Some option is there. You can make the not null as a normal one. Now check the timing. Already one key I dropped, right? Already we'll see. Earlier 670 milliseconds. This time 324. If you drop the not null also, it will comes to 173. So either dropping constraint or you just exclude the constraints while inserting the data. While inserting data, I will say, hey, don't follow the constraints. I can do that one also. Constraint exclusion also. Okay. So that is the best option. Or else some people what they will do, whatever the constraints they have, they will drop it first. They will do the data loading. Later, if possible, they will create it. That one is possible. And one more important thing, auto commit. By default, auto commit, right? For example, if I am creating 1000 insert statements at a time, what will happen? 1000 will be committed one by one. So it's a bad thing. Instead of committing 1000 one by one, what I will do? I will keep transactions in begin and end transaction mode. Begin mode and end transaction mode. In middle, I will keep the statements actually. So what will happen if I keep like that? If I keep like that, at a time it will commit once, right? It will not do one by one. It will save a lot of resources. One by one, it will not commit. All the 10 statements at a time it will commit. What is the bad thing here? Good thing, okay, one time it will commit. Bad thing, in middle something went wrong. It will roll back completely, right?
It will be roll back. Yeah.
Roll back complete. So that's the problem. Anywhere, one good way, one bad way, anywhere it will be there actually. And one more important thing. Instead of multiple insert statements, go with a single statement. That is good. For example, see, let's take the time. Insert into employee values, see, 2.9 milliseconds. 2, 3, 4. This is the multiple insert statements. 4 statements, how many times? 2 milliseconds, 4 twos are. Average 8 milliseconds, right? 4 queries, 4 operations, average 8 milliseconds. For example, instead of like that, what I will do this time, insert into employee values 1, 2, 3, 4. Okay. See what happened. Here 6 milliseconds. If you add multiple also, no problem. 5, 6, 7, 3. Almost 7 or 8 records, 8 milliseconds only. But one by one, if you go, it is taking huge time, right? Like that actually. Instead of multiple inserts, go with a single command actually. Or else keep all the records in one file, use the copy command. Copy command one we tried earlier. Okay. And remove the indexes. Indexes also burden while doing the data loading. Remove the index, do the data loading. Later, you can create the indexes. Now, catchy. If you remember, free-h, free-h, most of the times catchy will be there 1.07 GB. I don't want that much catchy. So I can drop the catchy. See, These are the 3 statements you can drop the cache. Don't run this query daytime. Maybe night time, if it is very night time, where work is very less, then only you can drop the cache. Okay. So cache dropping is don't do in business time. Free-h. See earlier 1 GB cache. Now how much? 348, right? 348 MB. It's completely reduced. All the cache got dropped actually. That is also good one. Next, any foreign key constraints are there, drop it. Required. Drop means don't drop blindly. Take the definition first, table definition. Take it, then you drop it. And see, dropping constraints, dropping indexes, dropping foreign key constraints, okay. After data loading, if you want to add it back, first you can increase the maintenance work mem. Why? Alter table is a which activity? Alter table is a maintenance activity. So that's the reason vacuum full reindex, those only original maintenance activities. But your alter table also one kind of maintenance activities. So that's the reason increase the maintenance work mem. Then you create index, you add the so and so column, so and so constraint, that and all you can add it after increasing the maintenance work mem. Next one, if you remember, I told one thing, checkpoint timeout. Default checkpoint timeout, how much? SUI from Postgres, PSQL. So checkpoint timeout. Checkpoint timeout. Default timeout, how much? 5 minutes. Every 5 minutes, checkpoint for process forcefully go to the dirty buffers and it will flush the any transactions in the dirty buffers actually, any modified data in the dirty buffers. So during huge data loading, every 5 minutes this flushing happening, it's a good or bad? During huge data loading, overnight they are going to do data loading. If I keep the checkpoint time at 5 minutes, it's a very bad. Let's make it a 15 minutes. Every 15 minutes it will do the flush actually. So some impact will be reduced on the system. See, water every 5 minutes this guy hitting me. Instead of every 5 minutes, let him hit 15 minutes once. At least he'll feel some relaxation, right? So that's the reason actually. And one more thing, better. Okay, if this system is not that much critical, disable archive mode. Disable archive mode and this one. What is that? Yeah. If streaming replication is there, stop that one also. Streaming replication also one kind of performance issue. The slave standby server will connect master, it will try to recover the data, right? That is also one kind of issue. Stop the replication, later you can build it. Archival mode, see, you may get it out. Hi Rambabu, how come I will skip the archive mode? Very simple, your archive command is there, right? Normally we are using copy command in the archive path. So simply this path replace with a /bin true. It will not take copy of any archive files. /bin true. Just reload is enough. And one more thing, after insert, don't forget to run the analyze. Okay, always best practice after data loading done, do the analyze operation manually. And one more important thing, if any of the table, if you are inserting data, definitely it will create huge number of war files, right? You can make your table as a, if the table is not that much critical, make your table as a unlogged in the sense, if you make any table as unlogged, it will not create any wall files. Okay, so if something went wrong, crash happens, there is no concept of point in time recovery. Okay, so do one thing, unlogged table, there is a concept called unlogged table. I'll show you that one. Go to pg wall, which is equal 14 data 15 data pg wall. In the pg wall location, go to pg wall, some wall files are there. What is the latest one? C 00C, right? 828. Log into the server, insert into employee table, select star from employee. So double table size, double I'm making almost table size double now. DT plus employee size 36 MB. Go and check how many wall files created here. Earlier C, right? C. So that to 828. After 828, how many files created? C? 4 files, right? C, okay. After C, D, E, F came, right? DEF came actually, 3 files created. So now, for example, if I make the table as a log, what is the latest time? 8:33, right? For example, you do one thing, alter table, employee, unlogged. Okay, set unlogged. Unlogged. See, I'm making the employee table as a unlogged table. D plus employee table. See, which table it is? Unlogged table, right? Not normal table. Unlogged table means this table related transaction will record or will not record in the wall file. Will not record. Do one thing, exit, take the latest file, 10, right? 834. 834 latest file. That means updated one. Now you do one thing, insert double the size, table size. So this time it should generate more wall files normally.
Ramababu, please repeat unlocked.
Unlocked tables will not create the wall files. So here see, I doubled the size, right? Doubled the size. I'm expecting 10 or 15 files normally. But 834 is the latest wall file. After that, any wall file created, I have inserted almost 35 MB to 40 MB data. Normally, it should create minimum 3 to 4 wall files. But not even single wall file created. Why? As you convert a table as a unlogged table. Unlogged table means that respective table transaction log will not be managed. If you perform any operation also, you will not manage any transaction log. Suddenly, this table dropped. Can I do point in time recovery?
No. You
Oh,
need to
why?
reload.
You don't have any transaction
Okay.
logs. So that's the reason point in time recovery for this table not possible. So what people will do, they will make it unlogged. They will do huge data loading. Later, simply they alter the table. Alter table, employee logged. Okay. Alter employee table set logged. Just make it logged. From next time onwards, it will capture the transactions actually. Okay. So you can make it this one actually logged. Log table, unlogged table. Next actually disable triggers. If anything having triggers actually, any table having trigger, it's a bad thing. Why? Trigger means one kind of condition, right? If I do here something, you need to do something. That is the trigger condition. So disable the triggers. Anywhere triggers are there, disable it. And one more thing, some people asked earlier, Rambabu, like tuning advisor, any tool is there to estimate the or get the suggestions where to create index, which column we need to create index. Yes, we have. There is a third-party tool, Pava. There is a tool called Pava. You people can install it and you can try it. It will be working like a Oracle tuning advisor. Okay, not exactly that much level, but up to certain level. This one also okay. Pava also okay. And one more thing, for finding sessions, every time I'm logging into the database, right? Stat activity, how many active, how many inactive, how many ID, how many blocking, these kind of sessions. I need to log in every time database. But we are very lazy people. So that's what we are not going with a, we will log into the server. Who will run the queries to find out details? What I will do, simply, I will install one software. The software name is actually PG activity. Just do yum install PG activity. Yum install PG activity. So this one, without running queries, you can get the result set. See, let me do that one.
Rambabu, like when we disable the constraints, like we disable the not null constraint and we do the data load. And after that, if we enable it, maybe
Not null one will not work actually. Not null unique will not work. For example, if your tool has duplicate data,
right.
not applicable for all constraints.
Yes. Okay.
It's updating all the previous things. Yeah, nothing to do. Already it's installed last time. So PG activity installed. Go to the Postgres and run the PG activity. See, OS level, not DB level. PG activity, just enter. If you enter, automatically it will connect to the database server. Okay, database server, and it will give process ID. database, application, user, which client, what is the CPU, memory usage, reads, writes, time, okay, these details, and which version, where it is running server, okay, and one more thing, what is the port, how much size, usage, and one more thing, active connections, memory usage, out of 1.8 GB, this one is consumed actually, like that actually, SAP, load average, all the details printing. This is which queries, running queries. See bottom, why waiting queries, blocking queries, there, right? Do one thing, just function 3, blocking queries. If you press 3, blocking queries. If you press 2, waiting queries. See, if you press 1, running queries. If you give space, see here, it's paused. If you give space, it will start again. If you enter H, it will take help. See, if you enter C, sort by CPU usage, sorting order by CPU usage. M, sorting order by memory usage. Number of reads, number of writes. For example, long running queries T. If you enter T, see for example F1. I go back, if I want long running queries time basis. Okay, I can give T. Then 100 queries or 200 queries, whatever it is, everything will be printed as a order by, which is the top time consuming query, time wise it will print it actually. If you enter Q, it will exit. Okay, so whenever you have a requirement, you can run it just like your monitoring script. This is good actually. PG underscore activity is good actually. Okay, like that. So this is the way. These are more number of points actually, more than enough actually. As a 8 years, 9 years experience PostgreSQL guy, if you follow one by one, it is more than enough for you. Everything included here in this. Okay, you no need to worry about other things. Included sessions related, activa, inactiva, idle, blocking, and this one actually table statistics and table sizes capturing and recommendations and how to reduce the cost and how to enable the indexes in the performance part. Okay, and what are all the action items can take to improve the load performance, and this one actually. So these are the things we covered actually, and the end of the day, if any new system, how we can give the optimization related parameters, that one also we done, right? So now you ask your questions. For I'll wind up the session today one. You can start asking questions. I will give answers.